welcome to my YouTube channel. Today, a very important chapter I will discuss the construction of analytic function by the help of a well-known method, Milne-Thompson method. So, what is Milne-Thompson method? Now, here we have to find the function fz, where you have given fz is equals to, suppose fz is equals to uxy plus I into vxy. So, this part is called real part, this part is called imaginary part of fz. So, if we are given the only one part of fz, that means either u of xy or v of xy is given to us, we have to construct the fz, that means the analytic function fz. More precisely, fz is equal to something like zq, where z is equals to x plus iy. We know, we don't know this fz is equals to zq. We only know, suppose fz is equals to, then fz is equals to x plus iy whole cube. That means this is x cube plus 3x square into iy plus 3x into iy I square y square plus I cube y cube. That is x cube plus 3x square yi plus 3x y square plus, this is I square means minus 1. So, this is minus 1, this I cube means this is minus I. So, minus of minus 3xy square minus I y cube. So, this we write x cube minus 3x square plus 3x square y I into minus y cube. So, here we are given just uxy is equals to, suppose x cube minus 3x square xy square. We shall find if z is equals to z cube. Or you are given v of xy is equals to 3x square y minus y square y cube. We have to find the z cube, if z is equals to z cube. So, only one part, that is either imaginary or real, are given to us. I have to find the function fz. So, it may it is, and it will be an analytic function. So, it will definitely satisfy the Cauchy-Riemann equation. So, how can I find this analytic function? So, let us start. Case 1, when the real part u x comma y is given. Step 1, how can I find fz? First, step 1, that means uxy is given. Find del u del x and del u del y. First, find del u del x and del u del y. And we say that del u del x is equals to phi 1 xy and del u del y is equals to something like, suppose this is phi 2 xy. Step 2, we here assume z is equals to z bar. That means x plus iy is equals to x minus iy, which implies y is 0. Y is 0, so z is equals to, x plus I into 0, so x. So here put z is equals to x. So put z is equals to x and y is equals to 0 in del u del x and del u del y. We know that fz is equals to u plus I into v, which implies f dash z, that is, we know that z is equals to x, so this is del u, we call it del u del x plus I into del v del x. By Cauchy-Riemann equation, we say that del v del x is equals to minus del u del y. So we this is by CR equation. So we write this as del u del x minus I into del v del u del y minus I into del u del y. This is phi 1 xy minus I into phi 2 xy. Put x is equals to z is equals to x and y equal to 0. So this is phi 1 z0 minus I into phi 2 z0. So that is this is f dash z. So this is integrating we get that fz is equals to integration phi 1 z0 minus I phi 2 z0 over dz. So this is a function of z, so we easily can integrate this function this part to get an analytic function fz. So this is case 1. Now case 2, when imaginary part is given. Really, it is imaginary part. Vxy is given. So here step 1, so same process. Step 1, first find del v del x and del v del y. Del v del x and del v del y. Call it, and del v, we say that del v del x is equals to psi 1 xy and del v del y is equals to psi 2 xy. Okay. Step 2, let put z is equals to x or x is equals to z by equal to 0 in del v del x comma del v del y. We know that fz is equals to u plus iv, which implies f dash z is equals to del u del x plus I into del v del x. By Cauchy-Riemann equation, we say that del u del x is equals to, we have to replace u, but because we don't know the u, we just know v, we don't know u. So replace u in place of replace u by v. So how can I replace u? By Cauchy-Riemann equation, because Del u del x is equal to, we know that this is del v del y, CR equation. So CR equation connect u and v. So this is del v del y plus I into del v del x. So del v del y is equal to phi 2 x y minus plus del v del x is equal to psi 1 x comma y. Putting z is equals to x is equals to z and y equal to 0, so get psi 2 z0 plus I psi 1 z0. So integrating, we get fz is equals to integration psi 2 z0 plus I into psi 1 z0. What is it to get the analytic function? So this is the process to find fz, to construct the fz whenever you are given just only real or imaginary part of that function. So we solve a problem on this method to understand in the better way. Problem: find the analytic function. Find the analytic function. Find the analytic function fz whose imaginary part is given v is equals to e to the power x sine y plus y cos y. So solution: so v is equals to e to the power x sine y plus y cos y. First we find del v del x. So del v del x and del v del y. So del v del x is equals to, so step 1, del v del x. So e to the power x sine y plus y cos y. We derive it, derivative of e to the power x is e to the power x into this constant plus e to the power x into sine y. E to the power x into sine y. And del v del y is equals to, this is e to the power x cos y plus cos y plus y cos y. This is minus sin y. Okay. Now, so we call this is as psi 1 xy is equals to psi 2 xy. Now fz is equals to u plus iv, which implies f dash z is equals to del u del x plus I del v del x. So this is equals to del, we know that function v, so this is del v del y plus I into del v del x. So since del u del x is equals to del v del y by CR equation, which implies, that means f dash z is equals to, so del v del y is equals to this, so e to the power x cos y plus cos y minus y sin y plus I into del v del x is equals to e power x sin y plus y cos y plus e to the power x sin y. Put x is equals to z and y equal to 0, so which implies, so let's see, f dash z is equals to put x equal to z comma y equal to 0. Step 2. So f dash z is equals to e to the power z x z cos 0 plus cos 0 minus 0 plus I into e to the power z x z 0 plus y means 0 plus e to the power z into 0. So this part is 0, so this is e to the power z cos 0 means 1, so z plus 1. Integrating we get fz is equals to e to the power z into z plus 1, so z plus 1 into e to the power z, this is equals to z plus 1 e to the power z minus this derivative of this 1, z plus 1 is this 1 e to the power z, integration of e to the power z into dz. This is z plus 1 e power z minus e to the power z, so z into e to the power z plus constant plus constant plus constant. So this is the analytic function. So fz is equals to z e to the power z plus c is the required analytic function whose imaginary part is given, whose imaginary part is given. So this is today's topic. Hope you are enjoying, and if you want to see more math, so please subscribe my channel and watching my channel. Thank you very much.